Okay, let us see now examples when we have solids. Whenever we have solids, we use now the volume of those solids. Unless when we have laminar, then we use the area. But for solids, we use the volumes. As we saw that weight is proportional to the volume, or the mass is proportional to the volume. Simple as that. So, from here, if we have now, if they want the center of mass, then we say volume times mass by unit volume. If we have the center of gravity, then we use the weight, which is volume, times the weight by unit volume. So from here, this is the radius. Sorry, the cone was removed from a cylinder of height h and radius r as shown below. So this was our case. So the radius show that the center of gravity of the remainder is at r to the comma to the h over 8 from the top. Now the one has to get it from the top there. So there we are going to consider axes. I'm going to consider this axis here and this here so that I can get my center of gravity. Then here recall these ones we saw them in our first lesson. We saw that the center of gravity of the cylinder, if it's vertical, then from here up to here is the horizontal distance. If you consider this as an axis from here up to here, then the vertical is from here up to here, or from here up to here is going to be the same because it's symmetrical there and it's symmetric there. When you consider cone, now from here up to here, if you consider the axis there, from here up to here, right, is going to be r, then the vertical. Now you can either consider from the vertex, if you consider from the vertex up to here, then this will become 3 over 4h from here up to here. If you consider from the base up to here, then it becomes h over 4. So this is, you can always specify from where. This is from the top and this is from the base. But if I tilt them, then this one comes here, then this one now will be now the horizontal, this one will be the vertical distance. As simple as that. So you tilt, you just interchange them also. You tilt also this one, you interchange. But because they are vertical, that's why I have my vertical distance like that. What do we need? You always get the weight and where it's located. So you first get, how do we get the weight? We are going to use this formula. We get the volume times the weight per unit volume. But we don't know the weight per unit volume. So we are going to first let. So I don't say let W be the weight per unit volume. Now, here I'm giving even the formula of calculating, but if you're in the paper, you can just state that weight is this, because you're going to just get the volume of this times W. Even the volume of this times W, just pass that. Anyway, so volume 1, let me call this one to be volume 1, and I call this one to be volume 2. So V1 is going to be volume of the cylinder is given by pi r squared h, meaning that r weight 1 is going to be, we get the volume times the weight by unit area, which we say is W. This is r weight 1. What about the second volume? From there, our second volume, V2, is now upon, which is r third pi r squared h. So this is our volume. Then together with its weight, we get the volume, which is r third of pi r squared h over 3 n times W. So that's the weight of this cone with ease. But now, remember this one was removed from this as we see. So now we need to get that. We need to know the weight of the remainder. So we are going now to get the volume of this cylinder minus the volume of this weight. I mean the weight of this which was removed. So, I say now weight of remainder. I'm going to get this, that this one was removed. So you get what? The whole, then minus what was removed. So I'm going to get the whole, which is pi r squared h W, then minus the weight of this which was removed, which is pi r squared h W over 3. You see this is a third, this is 1. So meaning the remainder was 2 over 3 pi r squared h W. Simple as that. Now, this is the weight that is remaining after removing that one out. Now, from here I'm going to do this. And then you see that if I consider the axes, if I consider these two cylinders, consider the vertical and horizontal axes as shown below. Now, some questions they will tell you using the line of symmetry, because this one is going to be symmetric with the vertical. So if the line is symmetric, it means that the r is going to be the same. I mean the exponent is going to be the same. About that, then you just need to get the y. You say from this to this, as simple as that. So now I'm going to consider the vertical axis and then the horizontal axis. I'm going to put this on, all those onto this. So this is my cylinder. There, it's going to sit there. And also that. So this one is what I'm going to call my symbol as that. So that's my cylinder. This one is my, let me consider it as my y. And let me consider this as my x. So we need to get the center of gravity of the cone and also of the cylinder. So now we can insert in our cone in that order. It's going to be in this order. Then this one is going to be here. Of course, we have our height h from there up there. From here, we have our radius r. And then we are going to be having the two centers of gravity. The center of gravity of the cylinder and then the center of gravity of the cone. So, this one here, so we say our V1 of the of the cylinder. So V1, center of gravity of cylinder. Cylinder is going to be, it's going to be for a cylinder, we say this is our V1. Of course, this is my V1. Then from the vertical up to this, I'm going to be having R. Then from the horizontal up to here, it's going to be h over 2. You just get the height divided by the cylinder. Then for V2 to be the center of gravity of the cone. So let me put it somewhere here. Let me put it here to be my V2. So V2 is going to be, now from here up to here, of course it's also around there. It's going to be R. Then, now I want from above, so from the top here or up to here, it's going to be 3 over 4 h from the top. From the top. Now we have the center of gravity, and now we have the weight. This one, the weight is holding. Remember, the center of gravity, the weight is going to act on the center of gravity. So this one is going to act at the weight, this weight is going to act here, and this weight is going to act there. So if I'm to put that one proper, so that let me screen and I put it proper. Okay, this one is what I'm calling V1, this one what I'm calling V2. So I can see from here to here. Now, if you consider it as, if you consider line of symmetry, it means that you just take the distance of the y, because it's going to be the same, because it's going to be symmetric about the x, about to the vertical, meaning that its x will be r from here to here, as simple as that. So from there, so this one is having weight 1, and this one is having weight 2. So now our center y bar is going to be w1, and where it's acting x1, y1. Then we subtract off the center of what we removed it. And its weight, the whole over w1 minus w2. So if we substitute in here, x bar, y bar is going to be our weight 1, we see it's going to be pi r squared h w. Where is it acting? It's acting at, this is the center of gravity for the weight traveling, which is R h over 2. Then minus weight 2, which is pi r squared h w the whole over 3. Where is it acting? It's acting at r 3h over 4. The whole over. When you subtract these two, we get 2 over 3 pi r squared h w. I think we see common things. So that all of this is common, this is also common, and divide through those things out. So here I'll be remaining with r h over 2, then minus r third r 3h over 4, all divided by 2 over 3. So from here, my x bar, y bar is going to be, I shall get this minus this. I shall get now r minus r over 3. Then here, when I get this minus that times, you get this minus this times that. So then I'll be having h over 2, then minus, when you get this, first of all, this and this are 3 is going to cancel, so I'll be having h over 2 minus h over 2. This one is going to cancel, so I'll be with 100 h over 4. The whole I'm divided with 2 over 3. So up there, we can simplify this, get 2 over 3 r. Then down, half minus a quarter, get a quarter h. Then dividing with 2 over 3. And when you divide, you can ABC, get 2 over 3 r divided by 2 over 3. And here I have h over 4 divided by 2 over 3, which we can simplify to. I think you see our x bar is going to be this one as will be made with r. Then instead of this one, I'm going to get a reciprocal, which will be 3h over reciprocal over 8. And therefore, and we see that therefore, our center of gravity is r, 3h over 8. As simple as that, as required from the equation. So, as simple as that. So, that's how we handle it. If the equation is specified, that's you identify the center of gravity about the line of symmetry. So, the line of symmetry, if it's vertical, you just give the y coordinate. If it's horizontal, you just give the x coordinate. As simple as that. So, that's it. If it's vertical, you say it's C. Now, if it was vertical, I'll say 3h over 8 from the vertical or from the line of symmetry. Then if it was horizontal, then I would have said if the axis was horizontal, you also give that as simple as that. So that's it. I wish you well.